Hey, my name is Alex, and in this series, I'm going to walk you through statistics and Python simultaneously in 20-minute sessions. So starting off with simple things like exploring our data sets and getting familiar with them, and progressing towards complicated things like regression, time series, and survival analysis. Those are things that junior data scientists and data analysts implement on a daily basis. So if you want to follow along by watching the videos, feel free to pause, slow down, speed up, but we'll do it in 20 minutes. And if you want to follow along interactively at your keyboard, then watch the setup video so that you can walk through getting the environments up and running, downloading the correct materials and code repositories, and I hope that you stick around for the really hard stuff down the line. Chapter 1 is about exploratory data analysis. That's getting familiar with your data. Look at it every which way and determine how to best approach the problem at hand. So we're going to work through these problems. We're going to skip redundant ones and skip some of the most basic stuff. First thing, import NSFG. That's the custom library specific to this textbook. Here is one function of that library that's going to process our data. That's mainly what it's used for. And it's going to return a data frame, which we're going to store in the variable called preg. A data frame is a table. If you're very new, think of it that way. The big takeaway is that in Python, we index at 0. So the nth row will be indexed at n-1. The next several rows are pretty basic Python stuff, how to access certain columns or rows or slices of rows or columns. Go ahead and look at that if you're totally new. If you are not totally new, you probably already know it, and we'll get started with the exercises. Select the birth order column and print the value counts. So that's printing the frequency of values, which gives insight into the mode or the distribution or perhaps some outliers that might occur once or twice only. So to do that, we have a pretty standard way of doing it. Call the data frame by name, dot, column of interest by name, in this case the birth order column, dot, value counts is the method that we're going to use, and we will sort the index for readability. Shift enter, here's our result. Quickly, let's go over that again. Data frame by name, dot, column of interest by name, dot. This is a built-in method. We're not going to write our own method because that's a waste of time. This is standard, it's tested. We're not paid to write everything from scratch. We're paid to distill valuable insight quickly and accurately. And we're going to sort these indexes. So, because we're familiar with our data, we know that this means first pregnancy for 4,413 women, second pregnancy for 2,874 women, so on and so forth. We have a few outliers here. It's possible these are real data points, but always take outliers with a grain of salt. That's why it's important to be familiar with the field. Okay, skipping some redundant cells, Create a new column, total weight in kilograms, and compute the mean. When you're creating a new column, you cannot use dot notation. So we have to use square brackets and quotes. Total weight in kilograms. Alright, and now we're going to take total weight in pounds and convert it row by row and stick the answer row by row in total weight in kilograms. Luckily, data frames allow us to conduct operations on entire columns all at once. So first, let's pull that column, total weight in pounds, and divide it by the factor 2.2. Okay, and now we need to compute the mean. By the time this current line is executed, the one above will have been executed, and total weight in kilograms will be a new column in preg. So now we can use dot notation, use the built-in method mean, shift enter. There it is in pounds, average newborn weight. Here's our conversion factor, so that should check out. It's about right. Okay, let's read in another data frame and stick it in RESP. That's the female respondency data. It's responses to survey conducted. Okay, let's answer a couple of questions. How old is the respondent with case ID 1? So age is stored as a column, age of the respondent, age_r, in this new data frame. So case ID is going to have to match 1. This is a Boolean statement. It's either true or false. Now, for every row in this data frame, specifically this column, evaluate whether or not it matches 1. Again, this is just a bunch of true or false statements. We want the actual data, so to do that, we do this. Give me all the lines of this data frame where this evaluates to true. That is, where this column in this data frame equals 1. And last, we want the age. So dot age r is the column. Shift enter. At index 1066, we have a 44-year-old mother. That's a little complicated, so here's a short diagram. Here's the data frame in its entirety, including case ID column and age of the respondent column. So resp.caseID, that is case ID in this data frame, evaluate this condition. It's going to either be true or false, so depending on whether it equals 1. And finally, instead of giving us this true or false value, give us the actual line of data where it is true. Of this data frame, give us all the lines where this is true. And that's how you pick the row. And then when you want to pick any specific column, do it with dot notation, dot hr. Okay, there's a couple more where you can practice. Just make sure that the field that you're looking for, that is the column you're looking for, exists in the data frame that you're calling. So in this case, hr exists in resp, we know that. But in this case, pregnancy length does not exist in resp, it exists in preg. So keep that in mind and go ahead and do these two for practice. The last few exercises in Chapter 1 have less to do with analysis and a lot more to do with data processing. So, if we open up the skeleton for the exercise, we'll see that we're importing NSFG and ThinkStats2. Those are custom libraries, and a library is nothing more than another file. So we can actually go into our file tree on the left here and find the NSFG library. And let's look at this here. It's important because it's actually the answer to our first task. We're asked to define a function that reads in the female respondency data. We should have known that there was already a way to do this because we actually use that data in the Jupyter notebooks. And in fact, here it is. Okay, and then notice that we import ThinkStats2, this other library, because down here we use this read stata dictionary function belonging to that library to do something. Let's go down here and look. ThinkStats2. This one is a lot longer, has a lot of classes, a lot more functions and methods. The point of these exercises is to illustrate how much work goes into data processing before any analysis gets done. If you're lucky, you'll have a team of data engineers that do the gathering, do the processing, do the cleaning, and then give you the data in a usable format. But odds are you're going to spend a lot of time with these sorts of tasks. So let's walk through it. It's not going to be very in-depth, but for the sake of completing the chapter and illustrating the point, we'll complete these exercises. So define a function. We're going to call it the same thing, read female respond, and it's going to process our data. We happen to know, because we read the chapter, that our data is stored in a dictionary file that is called 2002 fem resp.dct, and the second portion is stored in a dat file called the same thing, and we need to pass this parameter, which you would only know if you understood the initial state of the data and how to process it to get it to a final state. So if you don't want to dive too deep into that, don't worry about it too much. Again, it's a little more to illustrate just how complex things can be. Okay. First thing we do is create this dictionary object using the ThinkStats2 module, specifically the function called read stata dictionary. We're going to pass it that dictionary file. We read about stata dictionary files in the chapter. Okay? And then that dictionary object has a function called read fixed with. And to that, we're going to pass our dat file. We need to specify the compression type. And we need to pass it that parameter from the definition. And finally, we'll return our data frame. So this function takes this data in these two parts and this extra parameter. It creates this dictionary object using the ThinkStats2 library, specifically this read stata dictionary function, and takes the dictionary file, returns the dictionary object. That dictionary object class has its own functions, one of which is called read fixed with, that takes a dat file, a couple of other parameters, and returns our final data frame. And we're going to return that final data frame to whoever calls our function. Now let's write a little test for that. Resp equals read then resp. So we're going to actually call that function and read our data frame, stick it in resp. And then we happen to know that we have 7,643 records in that data frame. So we're going to assert that the length of that data frame is 7643. If that checks out, then we have at least a little bit of a hint that we process things correctly, and we'll print out all tests passed. Okay, so we'll run that in a little bit. For now, let's continue. The next task is to use the variable pregnum to cross-validate our data. So pregnum is a variable that exists in RESP. It stands for the number of times a woman was pregnant. So if a woman was pregnant 2 times, pregnum for her case ID will be 2. That also means that there should be 2 lines, that is 2 records of pregnancy in the preg data frame. And if there's a mismatch between pregnum and the number of records of pregnancy for that same woman, then our data, there's an error in one of our data frames. So we're going to cross-validate both of them using that variable. So define, verify, pregnum. We always want to name our functions intuitively. And we're going to pass it the RESP data frame, but we also need the preg data frame. Okay, and then we're actually going to make a pregnancy map. Preg map equals nsfg dot make preg map. Okay, so we're just reading in the pregnancy data frame there, and then here using the make preg map function, which is contained in the NSFG library, we're going to make a map from the case ID to all instances of pregnancy for that case ID. Remember that case ID that case ID is a unique identifier for a woman. Okay, and we're going to iterate through some stuff. So for index pregnant and okay, so items is a method that allows us to look at both the key and the value at the same time. So items, key, and value. At this index, this is going to be the value. And we're going to be looking at pregnum in this data frame. So this column in this data frame. Okay. What we want to do is return the case ID at our current index. So at index 0, let's get the case ID for that index. Okay. And then we're going to make a list of the rows indicated by some index where that case ID has a pregnancy. So basically, this is the woman, and this is the list of rows corresponding to her pregnancies. Okay, and we're going to go through each row of resp and find these two things. And within this same loop, we're going to check that the length of indices, or the number of records that we have for that woman, we're going to check if it does not equal pregnum for that same woman, that same case ID. If that's not the case, let's find out how far off we are. So for that specific woman, let's find out how many records there are and how many records there should be. And let's kick out of our function, let's return false. But if everything does check out correctly, there are no mismatches, then let's return true. Okay? And let's write a check for that function. Okay? So basically this is just going to call our new function. If everything checks out, it's going to return true, and this will be okay, and it'll print out all tests passed. If there's a mismatch, if the number of records for that woman does not match the number of records that there should be for that woman, then print out that woman's case ID, the number of records there are, the number of pregnancies that is, and the number of records of pregnancies there should be, and then kick out. Otherwise, it's okay. And the last thing we're asked to do in this chapter is to print the value counts of pregnum, but let's not do all of that because that's tedious. So resp.pregnum, data frame by name, dot column by name. Our method value counts by name, and let's just look at one index that we know the value of, 1267, because it's in the book. Okay, so it's just going to make sure that it's at this index of what this returns, that's the answer. It's going to make sure that that's true. So this is the way we run it. We go to where our file is located. We type in Python, and the name of the file, chapter 1, ex.py, enter. All tests passed. Excellent. So that's it. It's not super important to know this. It's very, very, very specific to this textbook and this data set, but it gives you insight into how much work goes in to cleaning, gathering, formatting, and outputting data before you can even touch analysis. So that's it for chapter 1, and chapter 2 begins with distributions.